Hello everyone, and welcome to the first webinar of the August series. So today we are going to learn about Corda, and we're also going to build a small application on Corda. So by the end of this webinar, you should be able to build an application on your machine, and then you should be able to deploy a small application on a local network using Corda. So that's our overall agenda for today. And so let's get started. Well, my name is Ashutosh, and I also have Irina here, who will be helping you guys with all your questions on the comment section. So please feel free to put anything over there which you feel you don't understand, and I'll also be looking at that from time to time. But Irina is over there looking at it all the time. We'll be answering questions for you. Yeah. So without much further delay, let's just get in. All right. So here we go. So before we start, here are a few references that you might feel important, and as you go through your journey in Corda, you might feel the need of one or the other. So I'll just run through this list. The first and the most important, I think, is the Corda Ledger Slack, right? When you are developing on Corda, you would need to help. You would need help, or you want to be in an environment where people are developing on Corda as well. So that's where the Corda Ledger Slack helps. It's a community of over 8,500 Corda developers, I guess, and not just R3 Corda, not just R3 developers or engineers. These are actually a community of developers from all over the world. So feel free to join there, and that I think it's a great place for you guys to hang over when you start developing with Cordas. And then developers like documentations, read documentation. So we have the Corda docs, anything and everything about Corda is over there. And we have a free training site. This is something I like the most. It's free and it gives you a very streamlined approach to how you learn Corda. Even if you're new to entire blockchain space, it has a section where you would learn about blockchain, and then it will take you through a smooth journey. You'll start with some simple things, and then it will move incrementally more and more complex things. That's how you would easily learn with that kind of a journey in or a storyline that you would have, be following with the free training. And then Git repository. Code is all we guys like, right? We are developers, we love code. So if you want to have a peek on how the Corda platform is written, it's over there. It's open source, so you could find it on our GitHub. So go on to github.com/Corda and you'll find it all over there. You can email us. The DevRel team is reachable at devrel@r3.com. And if you're a Twitter guy, you can use our official handles, which is @Corda blockchain and @inside R3. And do use the hashtags #Corda and #R3. All right, I talked about this a little bit in the beginning. So overall, the agenda is we'll just go a little bit in the theory part where we'll talk about what are the key concepts, what is Corda, how it's different from the other blockchains, and then we'll look at some of the key CorDapps, key concepts of a CorDapp, and we'll learn what a CorDapp is. So basically, when you build an application on Corda, we call that CorDapps. We'll go into much details of that, and we'll actually see how to build a CorDapp. So it's a hands-on session. We'll do some coding today. And finally, we are going to run the Corda app. So once you build it, it's of no use unless you're able to run it, right? So we will be running that Corda app on a local system. So we'll be creating a small network of Corda nodes, and then we'll try to run the application which we have just developed, right? That's what we are going to do in the next 1 hour or so. All right, so before we start, before we just jump right into the code, right, it's really important for us to understand what is Corda. So let's look at few of the things. So when you just listen of Corda, right, you must have heard this word, like it's a business blockchain. What does that really mean, right? We are not just a traditional blockchain. We call ourselves as the third generation blockchain. And why is that? Because we looked at all the traditional blockchains which were there in the market, and we try to see which one of them are more and more fit for businesses, and we try to adapt what are the good things in them while making sure that when we develop Corda, it becomes more and more suitable for businesses, and they're actually able to use this blockchain technology in a meaningful way in their business solutions. So that's where we took some design decisions, and that's where Corda stands out from the other blockchain platforms. And few of the things which Corda offers is it has a strong identity. Unlike other public blockchains, we do not have pseudo-anonymous keys as identities, right? You have real identities, you have real legal names, so you know whom you're transacting with. It's highly scalable. It provides great performance. You would see a lot of things on the internet as well around the performance of Corda. It just outperforms any of the traditional blockchain. That's because of some factor like privacy. Well, we learn about that. So I'll come back to performance. Let's go to privacy because that's important factor which adds up to the performance. And when you think of public blockchains, right, you would have this idea that when you do a transaction on a public blockchain, like for example, an Ethereum or even a Bitcoin, right? It's all public. Even you could go to some block explorer and then you can see what's happening in the blockchain. That's great in some aspect to some use cases, the transparency thing. But if you think of it in a business sense, right? What about some sensitive data? What about patents? What about pricing information? What would you do with these kind of information? How can you push it out onto everyone in the network, right? That's not a great thing to have. So that's where we give very much importance to privacy. We don't want that the data which is there in the network just be dispersed to everyone in the network, just broadcasted to everyone. And as you put something into the Corda blockchain, it just goes everywhere. No, that doesn't happen. So any transaction within Corda, if there are two parties involved, the transaction or the information about the transaction is just between those parties. So it's a point-to-point communication thing. There is no global broadcast available. So if there are 10 parties involved, then only the data about a particular transaction will be available with those 10 parties, while others, maybe there are 50 in the entire network, but the other 40 doesn't need to know what's happening because they are not part of that transaction. That's how Corda ensures privacy, right? So any transaction is point to point. You just say whom you're transacting with, and then that data is only distributed with those limited set of parties. But Corda as a platform, since it's a DLT, it will make sure that whoever has a particular piece of data, if there are n number of parties who have a particular piece of data, then Corda as a platform will make sure that these parties see the exact same view of the data. That should not be the case that they see different views, like one is seeing a different version, other is seeing a different version. No, that doesn't happen. If two guys know about the data, then they will know about the same version of the data at any point of time, right? So let's come back to performance now. When we say performance, why does Corda outperforms others? Because in a public blockchain, like the transaction has to be processed by each and every node, right? So as and when your nodes increases, the time it's not scalability. It's not scalable, right? More and more nodes brings in more complexity because it has to be processed. The transaction needs to be processed by each and every node that's there in the network. But it's not the case with Corda. The transaction has only to be processed by the nodes who are involved in the transaction, which pretty much brings a lot of performance benefits. And it also scales. It doesn't linearly depend on how many number of nodes there are in your network. There might be tens and thousands of nodes in your network, but there are two nodes participating, means there's two nodes involved in a particular transaction. Only those two nodes do the calculations or do the processing. So doesn't matter how many nodes in the network, it's highly scalable, right? Global interoperability. So we have this view of having a global interoperable network, different business networks being part of a single global network where you could transact without any boundaries, right? So each of these business networks could do businesses among themselves while also being able to transact assets with other business network. That's one of the initiatives. If you have heard of the Corda global network, or or better known as the Corda network, that's our step to a global interoperable network, right? But it's not a R3 thing, but we support it. It's a non-profit organization and it is based out in Amsterdam. So they handle the entire operations or the entire thing of Corda, but yeah, of the network. But yeah, R3, since it's a Corda network, we do support that network as well. And the next thing is consensus. Like any other platform, any other blockchain system or DLT system, consensus is important. So is it's important in Corda as well, and it's achieved by by a component called notary, and we'll learn about that in more details. But as and when you do transactions in Corda, each and every transaction goes through a pool of notaries. So there could be multiple notary pools in your network, and then you choose which notary pool you want to send your transaction to, and then that notary pool will give you a final say. Like it will give you notarize your transaction for that matter, and once they have notarized, only then the transaction is considered to be final. Right. So when we say notary, you could have these are notary pools. So it's not a single notary, it has multiple nodes running in a pool, and there could be multiple pools as well. So considering one pool, each of these pool could run a consensus algorithm, which is pluggable. So you could run a consensus algorithm depending on your needs. It could be a very simple algorithm like a raft, or it could be something more complex like BFT or even proof of work for that matter. I don't see why someone would use proof of work, but that's also a possibility. Anyways, and the final thing, it's open source, so nothing is hidden. You know what's out there in the platform. Just go in, look at the code, and you know what is written over there, what it's doing, right? Um, so yeah, so coming back to giving the emphasis on the point-to-point thing, that's just looking at it from a network point of view. So if you have multiple nodes, right? If you have three nodes, let's say Colorado and then Titan Tech, Bay Transcorp, these are the different nodes. You come to know that they have a public key, which is generally required. The crypto environment or the crypto infrastructure is really required in this in a blockchain scene, because you need to sign transactions and all these things, so you need key pairs. But it's just not the key pairs, you also have the names, right? These are legal names which I was talking about, and then any transaction between these parties will be point to point. So if Colorado does a transaction with Bay, then that information about that transaction is only with Colorado and Bay, while Titan, being in the network, will know nothing about the transaction. So they will have no idea that there is a transaction that has happened between Colorado and Bay Transcorp. Similarly, we have the notary pool. Like I said, it's a pool. It's not a single node. It has multiple nodes, and then they will do some consensus between them to come to a conclusion that whether a transaction should go through or not. But the major purpose of the notary is to prevent double spending, right? It doesn't look at the transaction. Now, if I say every transaction has to go to the notary, you might say that it's a privacy leak, right? The notary is seeing what's happening, while we say we do stress so much on privacy. So notary doesn't look at what is the data in the transaction. All it looks at the structure of the transaction. Just look at it from a very high level and understand whether there's an attempt to double spend. If someone is trying to do a forged transaction. If you want to go into the details of how it works, just get hold of me on public Slack. I'll give you good information. I'll give you the information on how that works. But yeah, for now, it doesn't really look at what the transaction is composed of. Rather, it just looks at the structure of the transaction. How many, what is being sort of put as input, what is being produced as output, and these kind of information. It will come to a conclusion whether there is a double spending attack or not. So unless you see what's in the transaction, your transaction is private, right? So it just doesn't see what's there in the transaction. All right, so that's a notary. Now, this is our small network. Like we talked about the global Corda network, right? That's our vision going forward some years down the line. So a Corda network can be thought of as a logic. It would have a logical boundary, which is your doorman, which is controlled by the doorman, right? When I say it's a permissioned network, you don't really it's not a public network, right? So you have a legal name, and where does that legal name come from? That legal name is basically provided by you as part of your KYC process. So whenever you want to enter into a Corda network, it's not like something like Ethereum or Bitcoin, where you just download the software, run it on your system, and you're up and running. You're connected to a network. It doesn't work like that, because we don't allow anonymous identities. We need to do a sort of KYC where you would need to say who you are, so that you'd be assigned a legal name, a legal identity, right? That's where the entire Corda network thing comes, and you have a logical boundary where you could say which is controlled by the domain or the identity manager. So you need to go to this guy, and you have to provide your KYC information. Only then he'll onboard you into the network. And then once you're in the network, your information will be stored in a directory where others will be able to see who you are, and that directory is called as the network map, so that you are discoverable by everybody else. So any node that joins the network is updated in the network map, and others can see who the different other participants are in the network. So that unless you know there is someone in the network, you can't really transact with them, right? So that's how the entire Corda network things work. Now there could be multiple like these small business networks within this whole Corda network, each communicating with each other. So as you see, that if there are multiple business network, they could easily communicate because the information is there in the network map, right? So it's a big global network, intercommunicable network. So it would have different notaries, it would have other nodes, and each of these nodes might be running different Corda applications or Corda apps. Right, so we talked about Corda apps. What exactly is a Corda app? Let's look at it in a bit more details. Corda app stands for Corda Decentralized Application. Well, what is a decentralized application? It's an application which runs in a distributed computing system. If you're from the Ethereum world or just rather blockchain world, you would have heard the term smart contract, right? So in Corda, we call this, the Corda app is the smart contract for Corda. Right, so Corda apps are nothing but jar files. Well, these are which has all your data, so they are stored in the Corda nodes, and they will be and then the Corda node will be looking at what's there in the Corda app and will be running those Corda apps. All right, so let's talk a bit about what we're going to do in the live coding session today. So we'll build a simple Corda app, very simple. We'll just do an issuance of a token, right? So three things that will be need. So there are three files which we will generally implement. These are the states, the contracts, and the flows. We'll learn about what all these three components are. But when you develop a Corda app, right, these are the three components which we necessarily need to do. We need to have a state, you need to have a contract, and you need to have a flow. So before talking much about what we will be doing with our token, state, contract, and flow, let's look at what a state is, what a contract is, what a flow is, and then we can try and see how we could basically implement these things. Right. Well, so again, from the objective point of view, our Corda app is just issuing certain tokens. So if I am a user and there is someone else as a user, then I can issue certain tokens to these guys. So that token would generally in real world represent some real world some value in a real world scenario. But for this case, we're not going into so much of details. We're just doing it as a sample, which just to understand how things work in Corda. All right, so these are the components. We talked about states. So what are states? Well, states are the asset, right? If you can, these are the facts which are stored in the ledger. So when I say token would have some properties, like it would have some amount, it would have an issuer, it would have an owner. Similarly, when you talk about a vehicle, right, what are the different properties? It could have a model, a make, the fuel type, or the other things, like what is the color of the vehicle, and all these kind of things, right, which are the properties of the vehicle. So these are the things which are stored as part of a Corda state, right? All the things which are stored in the ledger are a Corda state. So when you create a token, you will have all these properties in that particular object, and that will be stored on your ledger, right? So that's your state. Now states are immutable, like any other thing in blockchain. Once you put them inside the ledger, you can't change it. So how do you change it? You change that by means of transactions. So as and when you want to change your state stored on the ledger, you just don't update that state, but you generally create a new state, and you put all your updates on that new one, and that store that back onto the ledger. While what that would do is it would create duplicate states, right? So what you would do to get rid of that thing is mark the previous one as unusable. So we say that it is consumed. So by consumed, I mean we mark it as historic, which means it was there as a fact in the past, but the current fact has changed, and that's why this particular state has been consumed or has been marked as historic. And there's some other state which has been produced as part of a transaction, which is the current, which represents the current the current fact on the ledger, right? So that's how the transactions work. But you can't really change things as you want. So there has to be some business rules governing those things, right? How do you change something without so if I allow things to be changed at randomly, anybody could do anything with you with our data, right? But there are rules which governs these changes, and these rules are coded as part of contracts. So contracts are your business rules, which you put in a file, and then this file is always run when you want to do a change onto your state, right? So these rules needs to be validated, and all of these rules need to be validated and need to be basically followed when you do a particular transaction. If any of these rules are violated, your transaction will be marked as invalid, or it will be marked as a forged transaction. Right. So final thing is the flows. We talked about state. We talked about how you would update them. But one thing that every business require is a workflow, right? When you do an update or you do a particular business action, there has to be a particular workflow which needs to be followed, right? For everything, there is a workflow. So these workflows can be modeled using Corda flows, right? So we'll talk in more details about how to write a flow. But yeah, just the point to remember for now is you need to write a flow to be able to write a workflow to be able to do some changes to a particular thing that is stored onto the Corda ledger. Now, how to do that? We'll come to that. Again, states are things which are stored onto the ledger, and they are shared on a need to know basis. That's how the entire model of Corda, an entire privacy model of Corda works, right? We said that data is shared on a need to know basis, that is point to point, right? So data is nothing but state. So states are generally the thing which are shared on a need to know basis. If there are two parties involved in a transaction and that transaction is completed, only those two parties know about an existence of a particular state or an update of a particular state, whatever the transaction is doing. So taking that thing into perspective, if you have these, let's say this, you see these circles, right, named as Bob, Carl, and Demi, all these things. So the bigger circles could be we are representing them as parties, and the smaller circles are the facts stored on the ledger. So you could easily see that Bob and Carl know some fact called 5 and 6, while others don't know about it, right? Similarly, there is a fact called 1, which is only known to Bob and Alice, while others do not know about that particular fact. So that's how nobody knows about everything that's there in the Corda ledgers. There is no global ledger as such, but it's just a subset of what you should know is known to you. Right, so just looking at our token state a little bit, because that's something which we will be implementing. What do you think our token would have? I think I just told this already. So we are going to go with the bare minimum here so that it becomes really easy to implement. We need an issuer, we need an owner. An issuer is the one who is issuing the token, and then there's an owner who is the one who is holding the token. And the bare minimum that we'll be needing is an amount, right? You won't need to have a token of zero amount. That's useless. What would you do with a token of zero amount, right? So we need to have an amount field. I think that's pretty much it. We don't want to complicate it, so just 3 fields should be enough for us. And then we'll implement that while we after we talk about the contracts and the flow a little bit. Right, so contracts are rules, just like I said, and then we talked about transaction. So anytime you want to do update to a state, you create a transaction, you have an input and you have an output. Input is something that was on your ledger and you want to update that, so you put this as an input to a transaction, and then output is your desired state, right? You have changed some facts on that particular state, and then you put that as an output. And this transaction is run through a contract. There are multiple rules in the contract, and if all the rules are obeyed, only then your transaction goes through. If all the rules are obeyed, then your transaction is recorded onto your ledger, or your update is recorded onto the ledger, while your input, which is here, was taken, will be marked as consumed or historic, which means you can't really use that anymore because it has been used already. Right. So what we are going to do is we have, and there is other thing which I would just mention briefly is every state is attached to a single contract, right? So if you have a token, there will be a token contract. If you have a vehicle, there will be a vehicle contract. So all these contracts will govern all the evolution of your states. But when you talk of, let's say, a vehicle, like, or even a token, there could be multiple actions that you could perform, right? One is issuance, that is, you want to move it to someone else. Similarly, for vehicle, you could do or create a vehicle, put it on the ledger, which is like issuance, and then you want to do a registration of the vehicle, you want to do a service of the vehicle, a lot of different things that you want to do, right? But how would one contract suffice to that? So for that, we have something called as a command, right? So command is the action that you perform, which represents what is it that you're actually trying to do with the state. And depending on that command, you could say that you could tell the contract that this is the command, and so the contract could identify which is the piece of logic that or the piece of validation logic that they need to run in order to validate that particular action that you're taking. Right, so that command is depicted here in this diagram as in the red arrows, which is your issue. Now, below there you see the small issuer, right, in a bracket. So that is the signature which is required um, for this command to be successfully executed. What is a signature, right? So these are parties who sign to a transaction saying that they are okay with the transaction. So issuer is the guy who signs to the transaction. This issuer's signature is required for this transaction. Now, there might be other commands where you do not need signature of a particular party, right? For example, doing a registration of a vehicle. Let's say if you're registering a vehicle with, then probably it's only the registering authority who has the right to say what's right and what's wrong. Taking a hypothetical example, maybe some countries might have different rules, but yeah. So taking that thing, you as an owner of the vehicle, you just say that I want a registration of the vehicle, and the authority who is registering it will provide you with a registration number. You as an owner would not have much rights to say anything. So we could say that the signing authority is just the registering authority. So whoever is registering it is the only authority who can sign on the transaction. Things might change when you think of let's say servicing of your vehicle, right? So here the command is, let's say, service, and then um, and then um, and then when you go to a service center, you do you do a service of your car. Then this guy who is doing the servicing will sign the transaction saying that, well, I have done the servicing from my end, and you as a user might want to sign the transaction as well, or you want to have a say on that transaction, saying I'm the user of this car and I want to verify whether you have done the servicing correctly or not. So in this case, you see that you have two different signatures required. So the point here is every command might require different signatures, right? So command also holds the signers who should be signing the transaction. All right, I'm just looking at the chat a little bit. They say, why is there no input? Well, the answer to this is an issuance transaction, right? So when you do an issuance, there's nothing in the ledger that you want to consume. Like I said, when you do a transaction, you are actually trying to update something on the ledger. So if you have a vehicle on the ledger, then you would take that vehicle as your input, and then you produce, let's copy that vehicle and do the update on the vehicle on that output of that. So you pick up the vehicle, you do the update, you create a clone, you do the update, and then when the transaction is completed, this new updated state would become your current fact on the ledger, while the one that you took from that you took from the ledger and put it as an input will become consumed, which means that is not usable anymore because that was history. Now, what is the thing that we are consuming in the issuance? The token is being issued in the ledger for the very first time. It wasn't there in the ledger earlier, right? So this is something which is being put in the ledger for the very first time. So there is nothing to consume. So that's why nothing to be put as an input. So no inputs. There might be similar cases where you would do an exit transaction. Like there would be a case where you have driven a vehicle for like 20 years, and then after that your registration has expired and your vehicle needs to be put out of existence. What would you do? You would use the vehicle in your ledger as an input, while you will not produce an output, which means your vehicle is going to go out of existence. It doesn't really, there is no most updated state of the vehicle available in the ledger. All right. So here are a few rules that we'll be checking for in our contract. We'll go to that when we write our states, when we write our own application, right? Now moving on, how are the states stored? So we in Corda there is no blockchain per se, but there is a chain. There is no block. I mean, but there is a chain. So the chain is the chain of transactions. You could say chain of transactions or states. Now, um, when you do transactions, your states are updated, and these all chain of transaction is stored onto the Corda ledger. That's how the transaction chain is stored. For you, we use the same UTXO model, which our which is used in blockchain, right? So whenever you use a transaction, I said that your previous input, which is being consumed, is not usable anymore. That's because it can't be used as an input to a transaction which is getting created after your current transaction. So if you see this particular diagram here, this is a UTXO model. It means unspent transaction output. So if I'm using this output here as an input in transaction 2, I cannot use this again in new transaction. And what is the thing that's restricting me from doing that? It's the notary, because that is the one who is checking for double spending, right? So if I use this again in a new transaction, that means I'm able to spend a particular state twice, which is like I'm able to do a double spending, which is what is not allowed, right? So if you're allowed to do that, consider this scenario: you have a vehicle and you're able to sell that to two different parties because you're able to do double spend. That's what is notary doesn't allow you to do. So we have this chain of transactions while there are no blocks as such. All right, coming to the flows, we learned about states, we learned about contracts, and coming to the flows. Um, so flows, like I said, is the business workflows which you need for any action to be performed. So there could be very complex flows in this world, right? You might want to gather data from a number of different parties, do X number of things while you do this. So it's more like performing different actions in a sequential manner. But let's take an example of a very simple flow, which is a two-party trade. Like you're just doing or transferring an asset from one party to other, or you're just selling an asset to some party, which is like just the two-party trade. There's no complexities involved. So what are the different things that you need to do? So there are certain steps that you need to follow from the Corda perspective, so that your transaction is actually valid and you don't do anything goofy in there. So first thing that you do is you propose an update. Now, what do you mean by propose an update? You create a transaction, you put an input, you do your updates, create an output, and then you say that this is the transaction which I want to commit onto the ledger. So once you have proposed an update or you've created a transaction, you check update. A check update is more like you're just running your transaction against the contract to validate whether it's contractually valid or not. Once it is contractually valid and you're happy with that, you just sign your transaction saying that I have run this. So provided you are a signing authority. So generally the initiator is always the signing authority. But yeah, still going ahead thinking about it, you sign the transaction saying that you're okay with this whatever update is happening, because you have validated this according to your contract and it seems perfectly fine. At this point, you'll send the transaction to your counterparty. There's the other party which involved in your trade. And then remember, nobody trusts each other. It's a network where people don't trust each other, so they need to run the transaction against their own contract to validate that whatever transaction has been proposed is true. And when someone says that they have run the contract, they've actually done that. You don't know that they have actually done that. So you need to validate it at your end. Node B will validate it, and once everything is fine, they will sign the transaction. And once that is done, they'll send the transaction back to the initiator, who is now ready to send it to the notary for their for his final approval or to check for double spending. Like I said, notary needs to sign each and every transaction. There could be multiple notary pools. You need to choose which notary you need to use depending on multiple different scenarios. One of them could be the latency, depending on how close it is to you. But there could be other business decisions regarding choosing a notary. We'll not go into that. But yeah, you choose a notary and you send it to him for his for notarization. And once the notary has notarized it, you are ready to record it onto your ledger, right? So your update, once your notary has actually updated, has actually signed onto your transaction, it could be then recorded onto the ledger, and that transaction is final. So there is no rollback after this. Once the notary has signed, it's a final transaction. You can't really roll back from there. All right. Now, it might seem like a lot, but this is just for the explanation sake. In practice, you would just call one or two inbuilt functions in Corda to achieve all these things. There isn't too much of complexity involved while doing this, which we will come to know while we develop our code, right? Which is right now. So we are ready for coding. Let's move on to our coding part. Well, we are not using a local setup here because that requires time to, not much that you need to set up. It just requires you to set up Java or an IntelliJ IDE. But if you don't have Java and stuff, you don't have the correct version of Java, it might take some time, and still it needs some time for us to basically get Java installed and stuff. So instead, what we are doing is we're using an online IDE, and I'm just typing it over here. Just go in here and you will be presented with an IDE. Just type ide.corda.net and you'll be presented with an IDE with a project preloaded. So just going to look at this project, and this our token CorDapp which I was talking about. We'll just implement this right now. In case you're interested to download it onto your local and try it out on a local IDE, there's nothing that's stopping you. Just go to this particular URL and clone the repo. This is where the code is, right? But I'll be using the online ID, and I would say for now, let's just, if you guys are interested to code along with me, just use the online IDE and you should be good. And then once we are done with this, you could always copy this code and try to run it onto your own local systems. So let's look at the structure of this thing a bit before we go into the coding part. So we have a main folder where we have a Bootcamp package. Okay, there's a, all right. Thanks, Arna, for answering that. And then inside Bootcamp, we have three different files called the token contract, the token state, and then there are two more files actually, not three, four. So we have a token issue initiator flow and we have a token issue responder flow. So every flow has an, not every, but most of the flows would have an initiator and the responder. So initiator is the one who is initiating the flow, and then responder is the one who is the responding the flow, like in our case of node 1 and node 2, node A and node B basically. So if you understand this, two nodes are communicating, right? So there has to be some flow installed on one machine, and then there has to be some flow installed on the other machine or the nodes. So they need to communicate between each other. So the initiator is the flow on the initiators first. So for this example, the initiator is the flow installed here on node A, and the responder is the flow that will be responding to the initiator's flow, right? So that's why we have two flows, one for one node and the other for the responding node. Right, so let's move to our state and try to see what we want to do. And then for your help, there is also an examples folder here, which you could just have a look and see how things work. While your Bootcamp folder, the token thing are not implemented, but the examples are already implemented. So you could just have a look at that and see if you are just stuck somewhere. And there is also solutions.md. If you're not able to follow with me or you're not able to catch up with the speed that I'm doing, just look at the solutions.md. It has the solutions in there, so you can just copy and paste. All right, we also have some test cases here, which we need to pass in order to understand that whatever we have written in our classes is actually correct. I'm not going into details of how these test cases are written. So we have a session later on this month where we'll talk about unit testing. But for now, let's just understand that we have some test cases which we need to pass, right? So what I'll do is I will just uncomment all these test cases. So I'll see some errors. Don't worry about that. That's because I have not yet implemented the state. And then coming to here, I need to implement the state. So what do I need? My state is just it's just the asset. So it's just the token which I want to represent on the ledger, right? First thing I need to do is I need to tell Corda that this is a state. And how do I do that? I need to implement the contract state interface. Right, and once I do that, Corda knows that this is a state, but it also gives me an error, and it wants me to implement a method called get participants. Now, what is get participants? We'll come to that, but let's first look what are the facts that we want to have in our state. We talked about this. It's pretty simple. All we want is three facts: the issuer, the owner, and the amount. But if you try to think about this, like the issuer, the owner, and the owner are actually identities. These are identities on the Corda network. These are nodes on the Corda network. So what is the data type that I use for a node, right? So Corda provides you with something called as a party class. So whenever you want to represent any identity, you could use the party class. And the party class, among others, have the keys and the certificates which are required by the party class, which are required to be implemented in the party class. So you don't have to worry about that. It has the public key, it has the certificates and all those things. So whenever you want to access them, you could access them. But the thing to understand is if you want to represent a Corda identity, you need a party class. That's issuer. And the next thing that I want is an owner. And finally the amount, right? And just use an integer. That's it. So we just wanted issuer, owner, and amount. The other thing is we want a constructor to be able to, we want a constructor, but I don't want to type, so I'll go right click, source actions, generate constructors. I'll select all these things, and then okay, so there you go, that will generate the constructor for me, right? And we also want getters and setters. These are all private, so generally we don't want the setters because it's immutable, and once we've created this, you won't want to update it. So we'll just need the setters. So again, I'll generate them. Right click, source actions, getters and setters, select all, and there you go. So that has generated all the setters as well. Just get rid of them because I do not need them. Doesn't matter even if they are there, but still I just want to keep it clean. The only thing is left is our get participants. So get participants, we know that Corda follows the privacy model, right? So how does Corda knows who should know about this state? That is what is defined in the get participants. So I need to return a list of users who should know about this. And who are the users? For me, the users are issuer and the owner, right? So I would return a list of issuer and the owner. That's it. So let me just verify everything works fine on the test. You can see that there's something called a little bit of a message here which says running test, and now that has completed. So if I click on that, it says that 4 of my test cases have passed, so which means I have successfully completed my state, right? It's pretty simple, nothing much to do there. State is just like a Pojo, right? Now moving on to the contract, and let's see if that could get any difficult. Now, what are the things that we want to verify in a contract? These like vague rules that we want to verify. We don't want to, and in real practice, in real use cases, this might be different, but we're trying to make it as simple as possible, right? Because this is your first application that you guys are building. The first thing we want to do, like for others, is we want to make sure that this is a contract, and Corda knows that this is a contract. So we implement the contract interface, and then we want to write some rules, right? So what is the rule that we want to make sure, since this is an issuance, we want to make sure that there is no input. We don't want people to be putting in input while we don't check it here, and basically consuming something while they are trying to issue the state, right? So we just need to validate that. So how do I do that? Now if you see, I have a transaction object in the verify method. So if I inspect this transaction object, I have input states. right? Which gives me a list of inputs. And I say dot size is not equal to 0. So the way this works is if you throw an exception out of this verify method, then Corda knows that something has gone wrong with the verification, and it will mark the transaction as invalid. And whenever you want to make sure that your transaction is verified, successfully verified, it just happens when there is no exception thrown out of your verify method. So as and when you encounter something incorrect, you just throw out an illegal argument exception, which will be caught by the Corda platform. So we just say throw new illegal argument exception and a little bit of a message, small message, which human readable message like 0 inputs expected, right? What next do we want to validate is we want to check how many outputs we have. This is more about the shape of the transaction that we are looking at the numbers, right? Coming to outputs, similar to input states, we also have a method called get output states, right? Again, the size here, we are actually issuing something, we're expecting one output, and why we are doing this is because we don't want someone to issue something else along with issuing a state, maybe issue a vehicle, which was not really expected. We are just expecting a state to be issued. So do the same thing here. One output expected. Again, we need to have a command as well, so just let's validate that. Well, generally you won't check for the number of commands depending on use cases again, but still if you have commands, you will be basically segregating your entire contract depending on commands. But since we are writing a single command, and also we want to make sure how to get a command from the transaction, so this what we are doing, just checking that we have one single command. So you have a get commands method which gives you all the commands, and then if you go for the size, it will give you the number of commands, and if it's not equal to 1, then you could say one command expected. Oops. All right. Before I move any further, let me just test this much of the code and see, according to my test, I'm doing everything right. So that would be the first 3 test cases. Uncomment and then run the test cases. Alright, that will just take a minute or so. Alright, so all my 4 test cases have passed. So there you go. And we see some sort of exceptions here. That's because we're also testing for negative cases, which you could see over here. I'm not going to the details of that since we'll be covering that in the next webinar. All right, now we want to test a few more things. That was more from the shape. Now let's get into the content of our transaction. So we know that there is one output state, but is it actually a token that we are issuing? So let's check that. So we say get output 0. So we can use an index. If you just look at this, it takes an index, and we already know that there is an output, so we can safely take the index there, and we say token state. If it's, but we need to make sure that we are using the not clause. It's pretty easy to forget that. Otherwise, you could be throwing an exception in the correct scenario, which would be not great, right? So we can say a simple message, token state expected, right? What next? Next, let's validate. So this is not really required in general use cases, normal use cases, but if you want to get the type of command, this is how you do this. Or you want to know what the command is, this is how you do this. So we are validating if we have the issue command exactly in the transaction. So how do we do that? not very difficult. It's similar to how we get the output. So you go to the, but it's not the command. So this is actually, the command is a combination of your type of the command as well as the signers. Like I said, command carries the signers as well, right? So if you want to get the type out of it, you will need to say get value, which will give you the type of the command. And then we say instance of commands dot issue, right? And where did this come from? This is right here that you have defined. So we have defined an issue command here. Similarly, you could just copy this, and so if you want a move command, all you need to do is just say move. That will make a move command for you. That's not what we are looking at right now, but yeah, that's how you do it. Not clause, I should not forget that. And then the message. Issue expected, let's say. You can write a better message, but we are running out of time. And finally, we want to check that we have a positive amount. We don't want to be issuing tokens with zero amount, right? So what do? We say for the amount, we need a little bit of a typecasting because we won't get the token state directly. If you should see the tx dot get inputs, you could see that the type it's returning is a contract state, while we need is a token state, right? So let's do typecasting. All right. No problem here. Yeah. So now that I have the token state, I can easily say get amount. And if it's not positive, then I can throw the exception. It's not copied properly. Okay. Positive amount expected. Right? So we're done with the shape part of our transaction. Let me just validate them and see if everything that I'm doing is correct. It's still here. Right, run the entire test case to validate everything is fine. It should take just a minute. Oops, things have failed, something has failed. I missed something. Let me check them one after the other. Perfect, this is fine. Okay, so this has failed, which is token contract requires the output to have a positive one. Okay, shouldn't we should test this in fact first. Alright, testing out the issue one, so just to verify if there's something wrong with that one. Yeah, so this has failed, and if I check this, alright, so there's something wrong with my positive checking here. It's wrong. If the token state amount is greater than 0, I want it to be positive, so okay, anyways, let's just leave that for now for the sake of time. I'll just leave this particular test case for now. and then we'll move on to the last one. And this one requires us to have the the issuer as the required signer. So what I will do is, how do I get the issuer from the transaction, right? I want to make sure that I have the issuer in the transaction. So in order to do that, where do we have the issuer? The issuer is in the contract state, right? So how do I get a contract state? This is where I got the contract state, and then what I do is I say if the tx dot get, or basically the token state. So this is where I have the issuer, right? So if I go and say issuer, and I need to make sure that it's the command has the list of signers. So I need to make sure that the public key of the issuer, which I can get using the get owning key, is or maybe the other way around. I need to make sure that we have um, the owning key of the public key of the issuer in the commands signing key, right? So if I go get commands and I say get signers and I say contains, oops, yeah, dot, so basically contains, we should have the issuer signing key, which is the public key, right? So I say token state dot get issuer, and from the party, like I said, we have we can get the owning key from within the party. So I do this again. I need a not clause here, and I can throw an exception saying issuer signature required, right? So this I can check in my last test case, which is this one. There is something going wrong here. Okay. Anyways, let's just leave it for now and move on to the states. I think there is some problem with this. We'll come back to this if we face any issues while deploying. But for the sake of time, let's move on to our flow. So right, which is this one. All right. So what do we want to do in the flow? We want to. It's pretty simple. We'll need a notary first of all. So how do I get the notary? So we can. I said that all the different parties are available in your network map. So you could get your network map cache, and then from there you could fetch the notary. So don't worry about these different lines. So service hub is something which your node hosts. It nodes the node hosts different services, right? So you can get one of the services from there, and from these service hub you could actually find the notary, right? So once you have the notary, then what you need to do is you need to create a transaction. To create a transaction, you have something called as the transaction builder, which is available to you as part of the Corda APIs. And how do we build a transaction? We say just say new transaction builder, and we need the notary here. Then we need to add the output state. There's no input state because this is our issuance transaction. So you could say add output state, and we need to create the output state first of all. So for that, this is which is our output state, new token state, that is that's pretty simple, but let me just auto complete this, right? And that's where we have our token state, right? So once we have a token state, we could add this as an output. So to do that, just say dot add output state, and let's remove this. So you have different type of different variations of the add output state. I can just use it using the add output state method without any further parameters. But there's one more thing which we need to do is just uncomment this particular line in the state, right? So I said that we have this particular uh, thing that every state needs to be attached to a contract, right? So in this case, we need to have our token state is attached to the token contract, which can be which is made sure by using the @belongs to contract notation, right? That makes our contract. And what else do we need is we need to add the command that we want to use in the transaction. So for that, we have this add command. And what is the command that we are using? It's the token contract dot issue command. Sorry, the command dot it's called as dot, what is it, commands dot issue. Okay, that's why. All right. So the other thing, we need the list of signers who should be signing this transaction, and that we need to pass in with the command. So that will be arrays dot as list, which is Java Yuki. Yeah. So who are our issuers? We need to pass the signing keys, which are the public keys. So the signing keys are issuer's signing key and the owner's signing key. Right. So that's it. That's pretty much it. Apart from that, it's pretty much what I said, which we'll be doing, a single line of code from the APIs. We need to verify, which is to run the contract. So just run the transaction builder.verify and it will run the contract for you. And then in order to communicate with our counterparty, we need to have to initiate a flow session, right? Which is done by using the initiate flow method. And you could just call similar methods to sign your transaction, and once your transaction is signed, you could send it to your counterparty to collect his signature. So generally, if you need to collect signatures from your counterparty, you need to call something called as the collect signatures flow, and this will make sure that it goes to the counterparty and it will collect his signature. But yeah, there is something else that you have to write in the responder flow to sign the transaction. So you'll have to write the sign transaction flow, which will basically be handling the signing of this thing. So yeah, just have this method in your responder flow. There's nothing else that you need to do. But you will see that there is this piece of code over here, and what is that used for is to make sure that if there is certain validation that you want to put in apart from the validations that are there as part of your contract. Like for example, we have the validation called token contract must the amount of token that is issued must be greater than 0, which for some issue we are not able to implement. But in any case, if you have any kind of a such kind of a thing that is other than what's written on your contract, like for example, I don't want to accept anything that's below, let's say 100, an amount is below 100. So in that case, we will be using this particular piece of code. So this will run, and if there is anything that is written here, any validation code, that will be run, and if that doesn't satisfy, it will throw out an exception. So again, this is not part of your contract. This is local to the node. So they want to run a particular extra logic apart from what's there in the contract. So yeah, that's it from the flow part. And let's see if I'm still facing any issues. I'll try to run the flow test and see if we are still facing any issues with this. All right. let's see what's going on here. Yeah, so it's taking some time because it needs to create some mock nodes within it so that it's able to run the flows. The flows are supposed to be run on nodes. So if you look at the test case as well, you will see that there are some mock networks and stuff which are being done. Again, this is something which we'll discuss in our next webinars. So for now, let's just go ahead with what's happening. So that it takes just a few minutes, a minute or so before you could get the result. And I hope we are able to run this successfully. Okay. I think there is some issue that we are facing with the IDE, but never mind. Let's just try to see if we can run the node. I'll just try to make sure that we can. In any case, we can try to run this on the local, but for the sake of time, I don't want to do that. I just but generally this should have worked. There is nothing that should fail. It's just that the test case is not working for somehow. But anyways, let's just try to run this from. So now application is completely developed, and let me just revalidate this if I'm doing anything wrong, which I don't think I'm doing anything wrong here. This line of code is perfectly fine. All right. Anyways, whatever is going wrong, let's not worry about that. I'll just considering that the application is done, the next step that we want to do is run this application on our on our nodes. And in order to do that, we need to first deploy the network. And how do you do that? Is you can, so there is a plugin that is available with the Corda App, with the Visual Studio Code, which is installed on this IDE, and you could say Corda deploy nodes. What that will do is it will basically create your node structures for you. It will create all the node artifacts and stuff for you, and once that is done, you could actually then go ahead and run the different nodes and start interacting with the nodes. So this is what is happening, and it has successfully created that. So that has worked because I hope this doesn't depend on some features of the IDE. Something has gone wrong. We'll have to figure out why the test cases are not working, but I hope that the application is still fine. Anyways, so what this would do is it will create a folder called build, and within that it will create a folder called nodes, and within that it will create directories for each of the nodes. Now what does these things come from? We've defined it with a Gradle task, which is available within the build.gradle. You see there is a deploy nodes. There's just a Gradle task which I have run, and this deploy nodes would say what are the different nodes that are available that we should be creating in order to test our application. So here are the different nodes which we have configured, and same nodes have been the artifacts for these nodes have been created over here in the build folder after we ran the deploy nodes task. Now the next thing that we want to do is run these nodes. So in general, when you run this on a local, it would bring up different terminals for each of these nodes, but since we are on the online IDE, we will use something called the run nodes task here, which will basically bring up different nodes here. See, in the terminal. So we have a notary, we have a party A, we have a party B, and we have a party C. So we just take this up a little bit, right? And the node is up, Let me go to party A, and you see that the node is up. And the way external world communicate with these nodes is by the use of something called as RPC, and that's what it has done. It has logged you in with the default RPC. And in this console, you could do multiple things like say help, which will bring up different help commands or different commands that you could run on the node. Once you have the help in there, you could see that we have something called flow, right here. When you say flow list, it should give me a list of flows that are actually installed on the node. And I see a token issue initiator flow, which is exactly what I have written. And what the deploy node task has done is it has created an application from my workspace, and it has deployed onto this node, which is available inside your Corda apps folder. This is the application which was built, Bootcamp dash Corda app. Right, like I said, the Corda app is a jar file inside the node, so that is what is there. And now we are ready to run the flow. So how do we run the flow? I can use a command called start flow name, which is this. I'll copy this and paste it. And what are the different parameters that I need? I need owner and I need the amount. Owner is, let's say, party B, and the amount is 100. And as I run this, oops, something went wrong. Right. All right. There's something going wrong with our contract. Okay, this is where the problem is. It has to be output, not input. So that's why we were getting all these issues. There is no input because basically we don't, it's an issuance transaction. We need to get the output from here. Now we should be all good to test this out. Let me run the contract again and see if it will pass. I hope it will. Okay, how can we test? Still have some issues yet. It is mostly because of my 0 not clause. That should be it. All right, last try. Finally, we are able to, so that was the simple error. This is what happens with live coding, right? You get something wrong and things just start breaking. But yeah, we are able to get this right. So let's just redeploy our nodes and run our, so yeah, once again, let me do the, make sure that our flow is correct as well. Run this one. This should work this time because there was a problem with the contract. Okay, so finally the flows are running. I'll just close our nodes for now so that we can do the deploy nodes again. Perfect. So our flows are fine as well. So we are all set. That was a little bit of an issue with the input and output thing, just a typo which created so much of problems. But yeah, it's bound to happen in live coding. Something goes wrong at times, right? But anyways, let's do the deploy nodes again. So to do that, we'll use Corda deploy node task. Nodes are already deployed. Yeah, I want to redeploy. And so what it's doing, it's generating the entire sort of artifacts which is required for the nodes to run, right? If you see generating node directories, and then you could see it's creating the network parameters and stuff. All these are things which network parameter is something which is required which is something which should be agreed by all the nodes at a network level, right? So it contains some common settings of the network, I would say. So yeah, we are done with the deploy nodes. It's time to run the nodes. Similar things happening again. Into party A. We'll wait for it to come up, and then we will be ready to run the transaction. All right, nodes are up. Let me just validate with the other nodes as well. Yeah. So our nodes are up. We have 4 nodes: node 3, party A, party B, and party C. And I can run a flow. I'll do again the flow list, which will give me the list of flows installed. Copy this and say start this, and enter. That will tell me what are the parameters that I need to pass to this. And it's owner, party B, and amount has to be, let's say, any amount, 100, for example. And you see, this is this little bit of a progress tracker which you get, which says which step your flow is currently, and then our transaction is completed. So I should have something on the vault, right? Something stored on the vault. So to see that, I can say vault query. So this is again a terminal method, something which we could run from the scratch cell here. And to run this, we need to pass the type of state that we want to query, which is passed by using the parameter contracts state type, right? And that is token state. And this has to be the complete path, right? The entire package name as well. So that's bootcamp.token state. Is that right? There is an R missing here. Has to be contract state. So this is, you see all the data that's here. Now state gets stored along with some other metadata which you could see over here, like I said, the status, whether this is consumed or unconsumed, and who was the notary involved, and other things like the time at which it was recorded on the ledger. But this is what we have put as part of the facts of the state, right? We had the issuer, we have the owner, and we have the amount. And we said that gotta make sure that if there are 2 parties involved, then they see this exact same view of the data. So party B should also see the same data, which is over here. But because of the privacy thing which Corda offers, party C should not see anything in its ledger. And there you go, it's completely empty, right? So that's it. That's how Corda works. We went a little bit over time because of the issues that we faced, but yeah, finally we were able to solve the issue, and we were able to run our Corda app successfully as well. So that's pretty much it from the bootcamp perspective today. And thank you for joining us. But before we leave, here are a few things that you might want to to look at. We do webinars every Thursday on or mostly every Thursday. We have a calendar for every month. So the August calendars look somewhat like this. We have an accounts workshop coming up, and then, like I said, we'll also be doing a unit testing workshop, which is where we'll be talking how we wrote all the different unit tests that you saw in this webinar as well. And they're all run at 2 p.m. at New York and India local times. So something to take away from here is, if you want to learn more, feel free to go to the free official training, which is, as I said, is a great way to start your journey with Corda. It will give you a very well storyline to start from something simple to learn more and more complex things in Corda. And the official documentation, obviously, where you will find each and everything that you want to know about Corda. You want to connect with us or the other CorDapp developers, join us on Corda Ledger Slack, which is at slack.corda.net. And finally, we also do office hours at every Tuesday and Thursday, which is like after 5 minutes, which again I'll be hosting. And that will happen on the Corda Ledger as general channel. It happens at 10 a.m. and 7 p.m. GMT time. All right. I hope it was a great session for you guys, and you learned how to develop a Corda app. I'm sure you guys will download or take a clone of the repository and try it out on your own. And feel free to join the Corda Ledger. Ping me. You know my name, Ashutosh Meher, and I'm happy to have you guys today. Thank you so much for joining, and I hope to see you in the next one. Bye bye.